Working with outliers. Depending on the shape of a distribution, if outliers are present, certain statistics are more appropriate to use than others. So we're going to look at the summary statistic, what it measures, and what we need to be aware of. So the mean is a measure of central tendency or location. It measures whereabouts the middle of the data is. But you need to be aware that this can be affected by skewness and also outliers, particularly if your outliers are at one end. It often gives answers that are not actual possible data values, such as 2.4 children. You can't have 2.4 children, but the mean can be 2.4. So it's just something to be aware of. The median is also a measure of central tendency. It's an average, if you like. That's not affected by skewness and outliers because we only look at the middle of the data set. It's a better measure than the mean if the data is very skew or has outliers. Now let's just consider what we're saying here. Suppose we have data that is very much skew. So there's a lot of data at this end and not very much data as we go along. And then we have an outlier out here somewhere, or maybe a couple of outliers out here. This will have the effect, both the skewness and the outliers, of pulling the mean in this direction. Whereas if we look at the bulk of the data, the middle might be here, the mean might have moved across to here. So this is the situation where the median might well be a better measure. It's more representative of the middle of the bulk of the data. The mode is also an average, a measure of central location, but it's used only when looking for the most popular value. For example, a shoe store owner would want to know the most popular sizes because he needs that information in order to order the right quantity of shoes in each size. The range is a measure of spread, or how dispersed the data is. We've seen the range, for example, on box plots. The problem with the range is it's affected by outliers. If we have a data set where most of the data is actually here, there might even be multiple same values. So most of the data is here, and then you get one outlier there and one outlier there, then the range is this, but it's not representative of the bulk of the data, which is actually in a much smaller span. The interquartile range also measures dispersion, and because it only measures the middle half of the data, the middle 50%, it's not affected by outliers. Finally, we have the standard deviation, which we know measures dispersion, and it's one that we've met quite recently, and we only really need to know how to calculate it on the calculator. But like the mean, the standard deviation uses every single data value, so it may be affected by skewness and outliers. For these types of data, it might be better to use the interquartile range. But with all of these things in statistics, there's a bit of a judgment call.